Hey guys, welcome back to Pre-Calculus, week of May 11th. This is going to be our last week of Pre-Calculus, whether you're a junior or a senior. We're wrapping it up this week. And so today we're going to be looking at some probability of independent and dependent events. This is basically a review from geometry. All of the probabilities that you're going to be doing are going to have the word and in it, and so we're going to be multiplying the probabilities. The independent probabilities will have nothing to do with each other, but the dependent probabilities usually has a denominator that reduces, or the numerator reduces as well. So just a reminder that probability is what you want over the total number of choices. Okay, so if I want to flip a coin, land on heads, there's one head out of two possibilities. Okay, head, and then you could have heads or tails. Okay, so that's just a quick review of basic probability. So hopefully you have a calculator. We're doing some calculating. This is a non-delta math topic. Okay. So this is going to go through just what basic independent events are. You got two different events. They're independent of one another if one does not affect the other. For instance, if you flip a coin and roll a dice. So you can't roll a dice and get a heads. You can't flip a coin and get a 4. Okay, so they're just completely different events. And so as I told you when we first started here just a moment ago, that you'll see this word and, which means to multiply. Okay, so we'll take the two probabilities that they give us or that we figure out, and we're going to multiply them together. So independent events have nothing to do with each other whatsoever. For instance, like this. If we flip a coin and we roll a 6-sided dice, find the probability of landing on heads. Okay, so we want to land on a head. So that means that our probability would be 1/2, because there's one head, two choices. And then when we roll the dice, we want to roll a 3. Well, on a dice, there's only one 3, so it's 1/6. So the probability of getting both of them, okay, getting a head and a 3 is a multiplication. So that would be, how do they have this set up? 1/2 times 1/6, which you really should need a calculator for, is 1/12. So that would be the probability of both of them happening at the exact same time. Okay? So that means it would happen one time out of every 12 rolls or attempts that you did. Okay? So basic probability. We probably did these exact problems with you back in geometry. All right. There are 52 cards in a deck. Hopefully you remember your cards. If you don't, let me know. I'll help you look up where they are. So a card is chosen random, 52 deck of cards. This replaced word is a big clue for independent. And I am not going to get that on there, the whole thing, okay? So the word replaced is a big clue for independent. All right, so then we choose a second card, okay? What's the probability that you choose a jack and then an 8? So our first roll, we want a jack. Our second roll, we want to get an 8. And so it's definitely going to help knowing your cards, but there are 4 jacks in the deck. So there are 4 jacks out of 52 cards. We're going to take that card, we're going to put it back in the deck, which means there's still 52 cards left in the deck. Well, how many of those are 8s? Well, there are 4 8s. There are still 52 cards left in the deck. We are going to, since it says and, we're going to multiply those. So this is really where the calculator is going to come in handy. So I'm going to use the TI-36 just because it's a little quicker. So 4 50 seconds times 4 50 seconds gives us 1 out of 169 tries that would happen. Okay, so it's not very likely that that's going to happen. So 1 out of 169 becomes that probability. You can do that also with your graphing calculator. I just think it's going to be faster with the 36X Pro. So if you did 4 50 seconds times 4 50 seconds and hit enter, and then you just hit your math enter button. So math, and come down and hit enter twice. 1, 2, and it'll give you the same 169. So I just prefer the 36X Pro in that situation. All right, it's experiment number 3. A jar contains 3. Start adding this up. 3 red, 5 green, 2 blue, 6 yellow. So we have 16 marbles. All right, we have 16 total marbles. Marble is chosen at random from the jar. After replacing it, there's that independent word, replacing. That means we still have 16 marbles after we choose. All right, so we're going to choose marble. Let's see, what's the probability of choosing a green on the first one? First one's going to be a green, and then a yellow on the second. So the second is yellow. Okay, so how many greens were there? There were 5 greens, so the probability of getting a green was 5 out of 16. What's the probability of getting a yellow? There were 6 yellows, 6 out of 16. There's still 16 marbles in the jar because we put the first one back. Okay, so 5 16ths times 6 16ths gives us 15 out of 128. So that's the probability of that happening. All right, let's see what we got next. Experiment number 4. School survey found out that 9 out of 10 students like pizza. 3 students are chosen at random with replacement. That means that the same kid can be chosen 3 different times. What is the probability that they all like pizza? Okay, well, the first student likes pizza 9 out of 10 times because 9 out of 10 kids like pizza. The second student, because they were placed back in there, still 9 kids that like pizza, still 10 kids that are total. Third kid, still 9 kids in the group that like pizza, and there's still 10 kids in the group. So you can shortcut that by doing 9/10 raised to the 3rd power. There's 3 of them, right? They're being multiplied. So that gives us 729 out of 1,000. 729 out of 1,000 that would happen. So it's pretty good chance that you get somebody who likes pizza all 3 times. 73% of the time, basically. All right, so let's transition over to dependent. Okay, so here with dependent, we were drawing the marbles and such. Now we're not going to put that marble back, and we're going to keep it. So once we start with like 16 marbles, and we keep one of the marbles, we no longer have 16 marbles to choose from. There'll only be 15. So what you're going to be looking for is don't replace. That's the key words here, okay? We're still multiplying, okay? We're still using the word and. So the only part it's kind of changing is most likely the denominator changes and sometimes the numerator changes. Just depends on the situation. All right. It's the same marbles we saw earlier. So we have 16 total marbles still. Same basic experiment. Except this time, we're going to draw those marbles, but we're not putting it back in. We're not replacing the marble. Okay, so the first marble is going to be green. So how many greens are there? There's still 5 greens. How many total marbles are there to choose from at this precise moment? there are 16. Now, once we take that marble out, and we're hoping that it's green, we're going to put it in our pocket, or put it safely. Okay, give it to a friend, but we're not putting it back into the jar. Now we're going to get a yellow. So how many yellows were there? I do believe there were 6. There were 6, but no longer are there 16 marbles. There are now 15 marbles in the jar. Okay, so we're going to do 5/16 times 6/15, because that's the green and that's the yellow. And let's see what that comes out to be. 5/16 times 6/15, and we get 1/8. Is that 1/8? 1/8. So the probability of that happening was 1 out of 8. It's a little bit different. Let's see, pull this back out. Marble problem from earlier. Last time, we had 1 out of 169. That's not the right problem. Get the right problem. Here it is. Here's the right problem. We have 15 out of 128, and that's 1/8. So it's a little bit different. Once you change the denominator from 16 to 15, that changes our answer. All right, 2 more problems here. Goldfish. All right, so you're going to go to, you're going to go to like PetSmart and you want some fish. Okay, so we got to figure out how many fish there are. There's 6 male and 4 female. So that means we have 10 total to start with. You randomly select a fish and we don't put it back. What is the probability that they're both male? All right, so this is what it looks like. We want our first fish to be male. Okay, so how many males are there? There are 6. How many total fish are in the tank right now? There are 10. We are going to multiply because they are both, okay? That both is a multiplier. Now we want our second fish. We also want it to be male. Now keep in mind what you have drawn. What is in your plastic bag that you've got water in it? Your goal is to have a male fish in that plastic bag right now. So we now want to draw a second male. Well, how many males are in the tank now? Remember, we took a male out. So now there's only 5 male in the fish. In the tank. There's 5 male in the tank. And how many males were there in the tank? How many fish were there in the tank to choose from the second draw? There were only 9. Because over here you took one away. You've got a fish in the back. So for those of you that need a visual, male, 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 male. That's 5 males. There are 6 males. 1, 2, 3, 4. There are 4 females. So on our first draw, there were 6 males out of 10 total fish. We drew one out. We said, okay, we've taken one away. Boom. Male is gone. There are now 1, 2, 3, 4, 5 males out of a total of 9 fish. And so that's where these values come from. That one male right there, he's already in the bag. Okay, we're already taking him home. Now it's time to calculate. So 6/10 times 5/9. Make it a fraction. That's 1/3 or 33%. So the chances of that happening, 1 out of 3. We have 10 fish to choose from. We want 2 of them to be males. 33% of the time, we will get 2 males out of that tank. Last problem. We got parts. So we've got some manufacturing going on here. And so a random sample of parts is coming off a machine. He found that 1 out of 100 parts. So this is your total. Okay, you've got 100 total parts. 5 of those parts are bad, which isn't very good. If he were to do a new sample, what is the probability that he picks a bad part and then picks another bad part if he doesn't replace. So here we have, that is our dependency right there. So we have first part, we want it to be bad. And so what's the probability of being bad? It's 5 out of 100. Okay, this is an and problem, so we're going to multiply. Our second part, we also want it to be bad. So we did not replace it. So how many bad parts are now still in the pool? That's right, there are 4 bad parts, because one bad part's already been chosen. How many parts are still remaining? 99. Because again, we pulled one. So now it's just a calculation. 5 out of 100 times 4 out of 99. Hit enter, create a fraction. 1 out of 495 tries, he will get 2 bad parts. 1 out of 495. Alright. So, this is, like I said, this was not a Delta Math assignment day. So there is a worksheet set up on the blog for you guys to download and work if you'd like to. For those of you that need the grade, you're welcome to submit this via email or Remind. And I'll grade it. I'll get in the grade book for you. Wednesday, we have a quiz. Yes, that's the 13th. To wrap it all up, it's just going to be on probability that we started last Wednesday. So if you have any questions, you guys know how to get in touch with me. Hope you guys have a great day. We'll talk to you soon.